Number two! Scared you, didn't I? All right, so let's do a little free body diagram there. Okay. So we got Lil M. That'd be a great name for a little physics-based rapper. I'm Lil M. Sorry, I'm bored. Okay, so we have F here. And then we have a friction force on little m due to big M. And I'm going to call this a normal force. I have a normal on little m due to big M. And then I have the weight of little m pointing down. And that's kind of it. And then for big M, I'm going to have the normal on big M due to little m. I'm going to have a friction force on big M due to little m. So that's congruent with this force. And these two forces are actually equal and opposite as well. And then I'm going to have the normal on big M from the ground, or from the floor. And that's it. So now let's write down Newton's second law equations, just to be clear. Remember, our goal, by the way, is to try to figure out what force actually keeps this suspended. And I gave you the fun equation just because I was feeling friendly. So, for little m, the equations that we're going to get will be F minus N little m big M equals little m times A. We also have that the friction force balances the weight in the vertical direction. And for big M, we're going to have that the normal balances the weight. And in the horizontal direction, the normal just makes the big mass accelerate. It's pretty exciting. All right, so let's go ahead, and I've actually recopied the equations from the previous page, and we'll go ahead and calculate capital F, the force necessary to keep the larger block from slipping down the smaller block. So to be clear, I know that friction on little m due to big M is mu times N little m big M. And with that in mind, I have the following. I also know that this friction equals little m times g, so I can do a little substitution here. So I have that mg equals mu n little m big M. And now what I'm going to do is a substitution here. I'm going to take this and put it into here and isolate the acceleration. So I'm going to get mg equals mu m big M times A. And so the acceleration of my system is mg over mu times m. So that's actually part D right here. But I'm going to use that now to get the contact force. So I have F minus, substitute, big MA equals little ma. So F over, big MA equals little ma, and then F equals big M plus little m times A. And now I can substitute, so I'm going to get that my contact force is going to be M plus M times mg over little mu times m. And that's the F necessary to keep the block from slipping. And it looks like we got part D for free as well.